Okay, I think it's time to start. Hello everyone and welcome to Future Radar Technology Roundtable. My name is Andrea Zanini. I'm about to manage this seminar. I'm advisor to the presidency of Council of Ministers. In recent past, I worked for technology in the Italian Space Agency and a Japanese multinational. And I am a contributor of Aspen, the magazine of Aspen Institute Italia. Today our goal is to understand the state-of-the-art leading technologies system, their evolution, their trends, and basically, if we can, to imagine the outcome in terms of future geopolitical challenges. We have here 5 super specialists, different sectors. From industry, and they have a lot to say. So to optimize the time, I would like to make 2 roundtable, so 2 questions each one. And before to start, let me say a little consideration that was very clear to me some years ago, and that consideration has been confirmed in the last month by the Ukrainian war. The trend of convergence between commercial space assets and the military space assets is running very fast. And this trend must be read in the larger picture where technological advance have led the development of low-cost sensing devices capable of providing high-performance system in defense sector. So I would start with Fabio Sterl, Director of Radar System Engineering at Leonardo. In today's world of defense and security, threats are directly proportional to the growth and pervasiveness of new integrated smart technology. What is the technological possibility of integrating sensor and electronic countermeasures in the architecture of defense systems? Could you explain with some practical example?
Okay, thank you. 3 minutes, okay, I try. I try. So, thank you for this occasion. So I try to collapse in 3 minutes, maybe a lot of information that have been already provided during the presentation of the day, and I was not able to follow all the presentation, but I'm sure that one point that has been addressed is the multifunctionality of the radars. Maybe my point can be a little bit extreme, but multifunction is a term that sometimes is overused, but is the need of the future. So we are moving towards direction where the one sensor has to perform a lot of activity from the radar point of view, but we are trying to integrate more functionality like the electronic countermeasure. So an example that we made as Leonardo with a cooperation with other industrial partners like Elettronica, SPA, was the integration of the radar with the electronic warfare system. So this was the first example where we tried to make the radar also a part of an electronic warfare system. Now, this convergence is in a way possible thanks to the new technology, to the smart technology, and also to the basic technology that we're seeing also today in HPA, digital transceiver. One aspect that has to be addressed in future radar architecture is at the end how we have to integrate this capability without losing the performances of the 2 systems. Really a practical example, because see, this comes from any customer. I would like to integrate any function in one system. Okay, the point, as in our life, I think that after COVID is now really one of the challenges, the time. So for the radar, the time is everything. And if you have to perform 2 jobs, in the same time is not feasible. So maybe you have to find new technique. But at the end, the time is the time. So if you want to jam an aircraft, you need time. And you cannot perform surveillance with the radar. So this convergence of this system at technology level, I think that started. And we have a practical example that I hope that we will validate with our national customer with other industrial partners. But the point is that with the new threats, today we also were looking at new threats, hypersonic threat, tactical ballistic missile, maybe maneuvering tactical ballistic missile. But we cannot increase what we require to the radar in terms of performances, in terms of radar, and in terms of multifunctionality. Because the time budget cannot be shared between functionality according to the final requirement. Otherwise, you have every time to find a trade-off. So first experiment have been done. We are already working on this. I think that basic technology will help us. But this is one of the challenge for the future. So new threats for the radar that will require more time to the radar. And so we have to find new technique to understand how we have to manage time between different activity, different mission. Because I think that everyone knows, and it's simple to say that if you have to perform jamming, listening, and radar, we have to face every time the problem with the electronic warfare system to share the time. Electronic warfare system wants to know when the radar is transmitting, but the radar needs to transmit. So the convergence is happening, but at the end we have to understand which is the perimeter of each system. And maybe the solution will be very near to the one that we are trying to test and to validate, that is the integration of more systems. So not one system that is doing all the jobs, but maybe integration of system. And this was, at the moment, is one, I think, of the best solution to guarantee requirements and multifunctionality of the radar. Of course, I'm speaking, let me say, my point is mainly affected by the fact that our customer is a military customer, so the performances of any system has to be guaranteed. We cannot say, okay, I can do everything, how, I don't know. The supersonic missile, hypersonic missile, has to be detected at 150 kilometers. This is the number. I cannot say, okay, but I have to jam, so maybe I will detect at 100 kilometers. I have always to guarantee 150 kilometers. So, given that requirements, we need to integrate other capability. To do this, we need new technologies.
Thank you. And on my left side, John Colts, Senior Director of Engineering and Technology at Analog Device. John, and the war in Ukraine clearly shows the importance of technological superiority, which translated in tactical terms means accuracy, timing, and effectiveness. At what point is the development of full platform for electronic warfare, rather military communication, etc.? SATCOM.
Okay, first and foremost, grazie per l'invito to this panel of distinguished researchers and technologists. So I'm representing Analog Devices. So the way we historically made chips.
Grazie. Migliore. Okay. So historically, we delivered chips, and the customers just take chips. Used to be called like a fruit stand. You buy an apple here and a pear over there, and something else on the other side. But in the last 5 to 10 years, across all our markets, of which aerospace and defense is one of our key market segments, we realized that we need to make it easier for our customers to adopt the technology, to get to a platform and a solution faster with even better technology. So in the last 5 years, we've put a lot of effort into building platforms, not only to help our customers, but it helps us understand the customer's problems better. We have a much better appreciation for how hard the work is to build an electronic warfare system. Even the multifunction aperture, exactly the comments. How do you make it as good as a standalone radar and a standalone electronic warfare, and at the same time? So we're trying to understand those problems at a much more internal way by building these platforms. So they also solve a lot of the problems, hopefully, of integration that used to exist. And hopefully we can make that problem easier to solve so that we can get to market faster with these very important platforms with the customer base in aerospace and defense across the North America, of course, in Europe and others. So we're learning as we go, and the platforms are not final products. We are putting in all the flexibility to make flexible systems, high-speed digitization, wideband systems that can cover all kinds of different applications. In the end, though, of course, every customer, every application has a lot of specialized software, specialized command and control, machine learning, and so on. So we're trying to understand how far should we go to accelerate things and make it so our customers can get to market faster and focus their efforts on the next level problem instead of how do you make an amplifier work with a data converter.
Thank you, John. And Maurizio Cicolani, MBDA, Italy Technical Advisor in Integrated System Innovation and Technology. And you are an expert of semiconductor, among others, of course, experience, yeah. There is a sentence I read on some publication, a sentence by supply chain strategist for Tesla, car maker. And he said it takes 200, 500 parts to build a car, but only one, not two. And that only one is the semiconductor. How much does the semiconductor crisis affect the sector of defense and security?
I'll try to give you an answer. It's clear that this is a big question because our product, but not our product in terms of defense, all the product need semiconductors today. The demand of chip exceed a lot the supply since 2-3 years ago. Probably is not the COVID the issue. I think that the problem is probably the fab have an insufficient capacity for semiconductor. This is, I think that probably this could be a big issue. But it's clear that there is another problem, that if I look what happened, what was in 1990, Europe, we probably produced the 40% of the total market. Today, we have more or less 10%. Because this is probably a big issue for Europe, because semiconductor, especially for defense, could have some limitation to export. This is a big problem. But it's clear that the question could be, but why the supply of semiconductor is not enough? It's clear that there are two main questions, two main answers. First one, probably there are not a lot of fabs, because also the market is very strange, because normally the semiconductor market is 70% is for communication mobile, 30% is for all the other. So, and the marketing for mobile communication is very short. The life, the product change every 6 months or 1 year. So this is not good for defense, where we have a product that we need to keep without problem for years, not for months. So this is a problem. Another problem probably is due to a long lead time to produce a semiconductor. So what means this? That probably we need investment. We need investment. In Europe, we need to collaborate more to find a new solution, putting in the center some fab. It's clear that we now we are speaking about general semiconductor, but microwave is a kind of semiconductor. For digital, there are other semiconductors. So it's clear that we have to cover what really we need in Europe. This is what I think. I don't know if I...
Just a short question, but what is the time window in Europe to drop this gap, in your opinion, of course? Very short.
Yeah. In fact, the problem is not only the investment, but to create a new fab, probably, I think that depending on the kind of fab, there are for microwave, for example, I think that 2-3 years could be enough. But if we want to create a fab for large volume, like could be ST, SGS, so in this case probably we need more time, 5-6 years. So this is the time schedule. That, in my opinion.
Thank you. Daniele Pistoia, Chief Scientist and Head of Technical Directorate of Elettronica. You wrote that electromagnetic spectrum is the key enabler for information dominance. What do you mean? No.
We are here because the electromagnetic spectrum exists. So since the Cold War, the potential for electromagnetic spectrum to be a key enabler for military application has become very clear to Western and Eastern countries. And now we fight against commercial application that use the electromagnetic spectrum, which are vital for the survivability of the nations, the progress of the economic progress of the countries, and so forth. So from one side, from both sides, the capability to exploit the spectrum is key for military application, but also for profits and for the commercial use. So what we see in the future is that this domain of operation will be much more contested and congested. And all spectrum-dependent systems, radars, radios, electronic warfare, navigation systems, and all the communication systems for any applications will be required to be more resilient entering in the spectrum, in the use of the spectrum. So this means that in the future, the system, the spectrum-dependent system will have to be designed in a different way, not exploiting the spectrum in a rigid way, but be more agile and adaptive in the use of the spectrum. Of course, the information is the key enabler of many economic applications, but also for the superiority of the military application. So this means that lack of information reduces the decision-making process, even in day-by-day applications. So we don't have to think that the electromagnetic spectrum is just used for military applications. Just a small portion of the electromagnetic spectrum is dedicated to military application. And in the future, we think that there will be a great overlapping between commercial and military application in the use of the spectrum, because it's limited resources. And so this means that anyone will want to use it for the activity related to the application itself. So this means that the spectrum-dependent system will be much more complex rather than complicated. So this means complicated, many different technologies inside. The complex means much more harder to manage. There will be, of course, much more software defined, but scheduler, as my colleagues were saying before, the scheduler, the management of the system will be much, much more harder.
So I don't know if I'm wrong, but when you design very well, it's a complex situation, but you design bad, is complicated to manage.
No, when I started as an engineer some decades ago, systems were 80% hardware and 20% software, something like that. And so the hardware included many technologies, from microwaves, video, mechanical technologies, and so forth. Not standard, designed for purpose, and managing the system was complicated. Today, the systems are more software-oriented, software-defined. The number of technologies inside is probably less, but the complexity of those systems, which is related also to the complexity of the environment, is much more higher than before. And so this means that not only there is the issue to enter in the spectrum, but also to manage the interference, the multifunctionalities, for example, a crowded environment in terms of threats and in terms of non-hostile sources.
Yeah, sources. Okay, thank you. Andrea Pompili, Chief Scientist of CY4Gate, so an expert of cyberspace, which became the terrain of where the wealth and prosperity of our society are built. And just for laughing, but you already knew this when you started to program for Amiga computer when we were young.
I was very young, 16-year-olds.
Just a little bit of time. We live in troubled times, and cyber warfare is a key part of the confrontation between states and something different of states, basically. How can an IT infrastructure can be defined resilient, secure?
Okay. I am here because you are here too. So because cyber is strictly related to everything that is related to the wireless, because what's happening today for military environments is that they are complex too, as Daniela said before. The real problem is that they are complex because software is complex. Currently, a lot of trouble are related to the supply chain, because the software is manufactured by other companies that build piece of software by other companies. You don't have the full control of them. And because a lot of software comes from open source, you have that a guy that developed something in US with no money, no paid, and so on, is the brick that manage everything of a complex system. And this means that in terms of vulnerabilities, so talking about what is the effective security of military systems, currently we cannot know this. The real problem, and we have a lot of experience coming also from the news or from real operations, is that there is always something that was not engineered since the beginning. Also, if we have a lot of regulations, a lot of standards that comes, unfortunately, from information technology. If you apply this kind of standards to the military environment, you have the problem that, in my opinion, if an hacker wants to enter inside the network, he can do it if it's software-based. But this is not because software is bad, it's because software is complex, and you cannot control everything. This means that everything has changed just 3 years ago. We changed it to the mindset. We don't talk about cyber protection, but cyber resiliency. Cyber resiliency, you know, means that you have a system that can be attacked. You can also obtain an hacker that is inside the system. The real concept is I need to maintain the performance of the system. So everything needs to be related to how can I maintain the same performances, how I can maintain the right functionalities of my system, also if my system has been compromised. This is the way it works. Now, the big problem with this is how I can measure the resiliency. And here comes the idea from John. The idea is the platforms. Because if you have platforms, you can virtualize them, you can create digital twins, you can measure in some way what are the effects of an attack that doesn't exist, because you can emulate attacks. Looking at the effect of an attack, and looking at the effect, you can measure the resiliency of the system. But this can be done only if we can have platforms that can put together all the models, the complex models, from software, hardware, everything, because unfortunately we have 20% that is hardware too, currently, that can support this capability.
Thank you. Fabio Ster, as second round, different types of complexity, different kinds of functional electronic countermeasures. What will the technological convergence look like now? And a component used on multiple systems, or the same system level used for different purpose? I think that's the second one.
Well, just to make you comfort, I have to say that this morning I met John's team. I was not really ready to have a technical discussion, but we were really, we spent 2 hours, so now I have 3 minutes, and I cannot synthesize 2 hours in 3 minutes. But, so the point is, as John was explaining, the technology is moving from component to platform. So from the small component that we were used to integrate in complex system, huge antenna, transmitter, receiver, a lot of units in our radars, now all these parts are collapsing. So what means this? This means that the distance between the system level and the component level is reducing. The problem is that the distance between component and system are reducing, but not the complexity. The complexity, I think, that is improving. So we have to face new problem, and the And this is easy to be understood since today I'm not an expert of component, but with your team we were speaking about details about a deconverter, processing, timing, microseconds, that maybe in the past was not required to the system engineer. So the system engineer was working really very far from the component, and now this distance is really reduced. But at the end, this is my thinking, so only my vision, maybe not correct. I don't think that we can reach in a small time the convergence of the system. But as Maurizio, I was following his presentation, I don't know if someone was listening the conclusion. Maurizio said a key words, I think, architectures. So in Leonardo view, our company is trying to understand which are the basic components that can be utilized on several architectures. But at the end, the architecture, maybe we have to understand that can be different. It is not possible with one architecture to make all the job, but the building block, maybe it can be utilized. So the nice discussion of this morning started with AESA radars. I think that is today's quite fashion to speak about full AESA, full digital. For sure, these are wide open architecture, so I'm sure that you can, let me say, adapt to your need, this architecture, but at the end, sometimes we don't need the full AESA. For some application, we still need the reflector. And I think that no one will convince me that we can utilize an AESA for some application. Think only artillery guidance. I think that it is not near the time to guide an artillery with an AESA, but we can work on the building block. So the elementary block that is maybe now the platform that is nowadays let me say the point of convergence. Then there is a perimeter that is still, I think, not well defined, where this platform has to arrive, and then where we need to introduce the software component. That is another point on the architecture. Maybe this will always be adapted, otherwise these architectures are not software defined. And this, the perimeter between this platform and the software component is nowadays, I think that is the challenge is defining this perimeter. Mainly because there are applications with the different needs and different requirements. So coming to the system, you have to guide an artillery, and I was asking to your guys, but how long you need to know the activity that has to be programmed? Okay, 1 microsecond, okay, good. This is good for some application. Some application, maybe space surveillance, can require milliseconds. That is, for a radar, maybe is 1 year, if we speak about milliseconds. But from some application, microseconds. So the perimeter is, we are not able, now at the moment we have not defined really the perimeter, but for sure the platform that are trying to put together radio frequency and digitalization are for sure, I think, the key element for the new architecture. Then maybe the surrounding environment has to be adapted according to mission, application requirement, and so on. But anyway, quite a difficult question at the moment, and maybe from the engineering point of view, the answer is not still is not available.
John Colt, how the new treats defining the investment priorities in this moment?
Well, that's a great question. I guess it ties into the conversations here because historically we've invested on making chips, designing chips. Now we're investing in putting these platforms together, hardware platforms. But hardware platforms, as you just described, require a lot of software. First layer software is just how do I point a beam here? How do I load the state of this complicated, complex system in? Very basic initiation and configuration. But then there's that next level of sophistication in terms of being adaptive, cognitive. We're thinking about these. So we're starting to invest. We've been investing beyond the chips on the platforms, which means we have to understand the system. And most important, I've learned so much by working with our customers, because that's where the expertise is. It's not textbook. You don't learn it in a book. You have to work with people who are really doing this, because the simple problems we understand, oh, it has to point here, but there's a next level and the next level of problems which you don't really know until you feel the pain. So we feel the pain. We try to feel the pain, because that's how we learn. So the investment increasingly is how can we make the customized software and the customized systems easier to get to from our platforms. And we're not here to design the radar. We're not here to design, oh, is it fire control? Is it air traffic control? Is it EW? Is it attack? We want to provide the building blocks, but make it easy to adapt and change. Try to solve the problems that are sort of universal, and so they can then be customized. And again, if we can help with the software that is also easy to use, it's really about ease of use and use of adoption. That's what we're trying to do, to make it faster, to take care of those simple things or first level problems, so that you can work on the more difficult problems, which is how do you maintain performance across different applications using the same aperture, or how do you do you deal with is it a phased array or is it a dish, and so on and so forth. So it's a very exciting time for us, because we feel we can breathe out and help fill some of the space and help our customers get to an answer faster.
Thank you. Maurizio Cicolani. I read some analysis about China. It's not about only the semiconductor, but in general advanced technology. And so despite the big aspiration, big investment, China is struggling to catch up with the US in economically and strategically terms. And China will continue to face important barrier. Do you agree with this analysis?
Okay, I can say that China is growing very fast in a lot of technology, probably including semiconductor. It's clear that we have not to consider in China Taiwan, because Taiwan is another thing. So,
we hope so.
Yeah, it's another thing. So, but it's true that probably the gap respected to the United States and other technology is still not so small. There is a gap, see. Because I know that China buys semiconductor from United States or for Taiwan, because in some simple technology, probably they covered the gap. They copied some radar, and when I visited China, I saw some radar that I knew very well. So, yeah, copied, but copied is not enough, because you can see the shape, but not the performance, and I'm sure that the gap is not covered. But what is, in my view, in my consideration, is really important, if we cannot stop the research, because China will arrive. So we have to keep the gap, because if we keep the gap, we can have a product that can save what really we need in the defense market. This is what I think. I visit a lot of companies in China. And it's clear that if you visit China several times, you can touch the growth. But it's important that we keep this growth. This is really important in my personal view. I think that at the moment there is big barrier. That is not a big problem. But in the future, probably, if we stop the research or we stop to invest money in the fab, this could be a big problem.
As you said before.
Yeah, exactly. Thank you.
Daniela, we are seeing the convergence of electronic warfare, cyber warfare, and AI-related technologies that represent a push towards dominance in cognitive spectrum. What collaboration is needed from government, industry, academia? So more or less is what our friend said before. So what kind of policies, maybe?
Okay. Starting from this last point, in the past, or up to now, closing the triangle among industry, academia, and government was not so easy and sometimes impossible. So there have been close relationships between industry and academia, because industry recognized that academia are masters of science, technology, research. They have freedom of action in the scientific environment. That's something that sometimes industry doesn't have, because we have not the freedom of action to work with any industries in the world. Chinese, Russians, and so forth, and so forth. And there are also issues related to competitions, of course, that makes these alliances and partnerships sometimes hard and huge and difficult to do. Government and...
sorry, I can interrupt you.
Yes.
Recently I read an article, I don't remember where, it said that there are a lot of European universities that are collaborating in important research with China's People's Army. Really?
Have freedom of action.
Yes, freedom of action and freedom of research, but they're just making the point about this.
Okay, and this is a point. Of course, government recognize that the industry is the key supplier of their capabilities. But there are some, especially in our business, there are limitations in the involvement of industry, of academias that cannot have access to some information, to some parameters, numbers, operational requirements, and so forth. So sometimes they don't want, but okay. So government, academia, and industry have, of course, three different goals, some orthogonal goals. So the government, they want to fulfill the requirement of their user, filling the capability gaps with technologies. Industry goal is profit, is make business, is make money. And any research is oriented to fill the product portfolio to be reused and, in many countries with different customers and so forth, to make money. Also, universities are moving to pure education to business. But of course, their goal is to increase their knowledge, expertise in the scientific environment. So these three goals that are so different must be put together. And I have to say that today the European Defence Agency is making an effort in this sense, with trying to put together these three entities. We have to think in a relationship more oriented to collaboration than to a pure supplier to customer relationship. And it has to be a win-win situation in which any party has its proper advantage. This is, I think, much more important today, where some technologies, artificial intelligence and cyber-related technologies, cannot be given to the user as a box. So the implications of introducing these technologies in the systems, whatever the systems, implies the intervention of the user to make the systems ready for the battlefield or for the use. It's not just a black box, but it's something that you have to train with data to trust if the output is not imperative or rule-based or something like that. So this means that the cooperation will increase the trust of the user in the systems that will be based on this technology, by the way, in the future. And without the industry and the academia, which are master of the knowledge, we risk a delay in the acceptance of these systems, new systems, by the user and the customer. This is what happens in the Western. Probably in the Eastern countries there are other kind of, for sure, there are other kind of relations that could represent a winning factor against of our adversaries against us.
And Pompili, as the last round, you know, in the last few months, we saw how was important, not only for the commercial purpose, the space infrastructure, which is the infrastructure of infrastructures, a super infrastructures, which is an opportunity, but is it also a threat? We saw the important images from Ukraine war done by commercial provider. It was a great novelty, if you can say that. For the first time in a war, we saw images of satellite which were not institutional satellites. CIA or other defense institution was Black Sky, etc. Of course, the major investors are the governments, but it's a novelty. And in terms of cyber security, what
yes,
would you say that?
This is the right example of what I've said before when talking about cyber resiliency. Currently, the space is the big problem in terms of cyber. Imagine that currently what has been done in space is more a paradigm that is called security through obscurity. No one knows how a satellite works, no one knows how a protocol works. So no one knows about this, no one talks about this, no one studied this, so this is secure by design, because no one knows how it works. Now the big problem is that because there is the need of technologies that comes from the commercial market. You know that Elon Musk is creating a lot of models for space, for example, CubeSat and things like this. There is currently a very big problem related to the fact that protocols are open. Hardware is open. They are using Linux, they are using Java, they are using technologies that are used in the information technology market. And they use them because it's cheaper, because it's faster, because they need to build platforms, and so on. There was just 4 months ago a competition for acres that is called HackSysat that was managed by ESA. They give a real satellite, and you have to break inside the satellite. There was 4 teams that created a lot of problems there. The platform was Java-based. This is a standard in the development world. And they have the total control of the video camera or about the sensors or whatever this is in the satellite. Unfortunately, they have to cancel this competition because one of the teams that was not selected for the competition disclosed the entire vulnerability before the competition. So no one can demonstrate that it was the best in the world. But the real problem is that also if we have satellites, platforms in space that are built using the original working model that is very strict because you have a lot of compliance, a lot of checks, a lot of validation. In space, there exist satellites that, like CubeSat that are not validated, they are built with commercial things, and they are free to work in the space. So you can use also this kind of items to destroy the other items. This is the problem of cyber resiliency. When you have in the same space technologies that are under validation and technologies that are not under validation, you have the problem that you can use these other ones. Imagine cars that can be used against a tank. Usual cars that you use in your life. This is the real problem that currently we have, and we are trying to study because here comes the problem of resiliency. We need platforms, we have to study this, we need to generate scenario, and this is currently the hard work, as Daniela has said before, that we are doing together with academia, companies, and government institution. Because they say, no, it's secure because it's disconnected and it's not real anymore.
Okay, we are just in time to close. Just one final question for everyone, but 2 words each one, starting from my right side. What are the key innovation and resources for the key innovation? So where come from?
No, this is a general question. It's clear that innovation is really important. You have always see in advance, you have to see what will happen, you have to understand when something is changing, like now. Resources is another key point, because normally I speak looking in Italy or in Europe, we speak about resources in general, means investment, means people, means competence, is everything. But probably we have, or the government in Italy, in Europe, have not a good view on the investment, because investment money that you put on the table probably are not enough for the speed that we need now. So, but on the other side, it's important that we create a collaboration between industry and university to create the right competence, because I know that the company have difficulties to find, to catch right resources. This is, my view, is really a key point. But more money and more resources. Probably we need that university is more closer than the industry to understand exactly what could be the change that they have to do to create the right competence.
Okay. Just sorry. One word, because the other words. One word for you.
I will be very fast. The key point for the innovation will be the integration, but just remind that integration doesn't mean interconnection. Many times it is simplified, the concept of integration, that means interconnect many systems. Integration is not is not interconnection. Quite huge, complex. It's tough. Resources, I think that the main point are the human resources. I think that we are facing, as Leonardo, a lot of problem in human resources research and human resources with technical skill. It is, maybe from my background, a little bit disappointing that during research of people, you cannot make technical question about maybe a fast Fourier transform. That is one topic that Alfonso likes, but we need the human resources with a really good technical skill to integrate the technological solution.
John?
John.
Very short. So you're American, you understand this.
Oh, very short. Well, collaboration for one, across the layers, you know, from the semiconductor to the system level, that's number one. A trained workforce, I think you just mentioned, that's absolute must. We can't all be doing TikTok videos and expect to put next generation systems in space. And the third one is diversity of ideas. We need to be able to bring different perspectives as part of the collaboration.
Thank you, John. Andrea?
Okay, currently, three things can be combined together. That is competencies, knowledge base, because you need knowledge, and technologies. For what are technologies, I think in the future is most important to reduce the time that you need to face some specific threats. This means automation or semi-automation is a key point that needs to be developed in the future.
Thank you. Daniela?
So for me, innovation is not the goal. The goal is to have a vision. If we have a dream and something we want to seek, then we can create innovation. Otherwise, we are poor souls in a desert. Then all the medium that they have said, integration, collaboration, and so forth. First, having a dream.
Daniela, thank you for your vision. I never know words after your sentence. Thank you, everyone.